Alrighty, in this video what we're going to do is we are going to start putting together our testing framework. Now we've seen an example of how we can put together a client. We're going to be repeating this process inside of Unity here in the next upcoming videos. But for now, I really want to get two sets of tests kind of going. I mean, first of all, we do have some things that aren't implemented yet. Like if we look at the systems operation writer, for example, we haven't done any deserialization of the result. We haven't worked on our RPC response implementations or anything like that. So there's definitely stuff that still needs to be done, and I want there to be a way to test that. So what I want to do is I want to create two sets of tests, each with their own little infrastructure. One of these sets is going to be a test that is just for the framework. So these tests are just about testing the framework. These are the tests that we'll be using to test things like when we make our actors framework and put together some simulation, all that fun stuff. Although those tests are going to be a little bit more complicated with some multi-threading. But yeah, so those tests are just going to test the framework. So for those tests, we're going to be providing mock servers and mock clients as far as components go. And then another class of tests I want to put together, they're basically going to be creating the real server components, but fake client components, if that makes sense. So yeah, let's go ahead and get started on that. So again, one of the big things about this whole framework is that it can live in memory if we want it to. And I think that's where we're going to start, because we need some sort of way for us to create tests that happen in memory and in process and don't rely on Photon running and don't rely on actually establishing a network connection. For that, we need some sort of object that will sort of handle the communication between the in-memory server and the in-memory client. There has to be some sort of glue in between there. And what I'm going to do here is I'm going to create a new implementation of a server transport and a client transport. Remember how we have the client transport that's responsible for handling communication from the client and the server, and it's an interface. And we also have the iServer transport, which is responsible for communicating between the server and the client, and that's an interface. And they both live in their respective assemblies. But what I want to do is I want to make a class that implements both of these interfaces, and then instead of shooting the requests off into Photon, it does it all in memory and in process, which makes or allows us to write tests that will run very efficiently without having to spool up an actual Photon instance or anything crazy like that. So that will allow us to flesh out our framework and work more on our framework so that we are not reliant on manual testing, because that's going to be problematic, especially as the framework grows. And so again, there'll be two classes of tests. We'll have our isolated tests and our real tests. And I consider both of these to be kind of under the umbrella of what I would call an end-to-end test. So that's what we're going to do. We're going to go ahead and go into our test project, and we're going to get that process started. And like I said earlier, the first component that we're going to have to put together, the first class we're going to need, is going to be the transport that implements both the client transport and the server transport. So let's hop over into our test assembly and create a new namespace. And I'm going to call it end-to-end. And then inside of end-to-end, I am going to go ahead and just create one class. It'll have different namespaces in it in a moment, but for now we're just going to start with one class, and it's going to be called in-memory transport. Now, again, in-memory transport needs to implement both the client transport and the server transport. But if you recall, we have a base type for the client transport already established. And since we need all that functionality to actually do our tests, things like handling the callbacks and all that fun stuff, what I'm going to do is I'm going to have the in-memory transport actually inherit from the, what did I call that thing? The transport base? The client transport base? Yeah, client transport base right there. So we're going to go ahead and have it implement that, which will import the client infrastructure namespace. You'll also see that we'll have to generate or implement its members. So let's go ahead and do that. And as you see, we get the send operation internal method. So really the only thing we need to do in our in-memory transport as far as the client is concerned is handle the send operation internal method. And really all that's going to do is it's going to just shoot that request over to a client context. Remember, the client context is the server's representation of a client. So all this method's going to do is shoot it off into a client context. Before I do that though, I do want to go ahead and implement the other interface. So now we implement iClient transport, which is good. So let's go ahead and also implement iServer transport. And then we'll go ahead and implement his members as well. And his members are send data and send operation request. So what I will go ahead and do is I'll go ahead and just make things a little bit more clear by regionifying this. I typically do not use regions very often at all. I mostly discourage their use, but this is a very interesting class in that it has these two responsibilities, one for the client and one for the server. And because this is all happening in process, it's very important to delineate when we're working on quote server code or quote client code, because that changes exactly what we're doing. We have a few more strategies that I'm going to implement later on that also enforces that separation. But it's always important while writing these tests to know if you're working on a server object or a client object. Otherwise, there could be a lot of confusion. Okay, so the server transport requires us to have send data, which sends data to a client, and send operation response, which tells the client to respond to an operation. So let's go ahead and before we implement these members, we do need one field, and that's going to be a client context. So I'm going to say public client context, server client context. Now this is going to have a public getter and a public setter. I know you guys know that I'm not a big fan of having a public setter on things, and that I would instead prefer this dependency being injected into the constructor, which is what I would typically do, but as we've seen with other bits that use our transports, it results in a circular dependency because our client objects need to be instantiated with the transport, our server objects need to be instantiated with the transport, then we need to register those instantiated objects back with the transport. And if you recall, the client components can register themselves back into this transport after it's constructed by adding an event reader, I guess, to it. Okay, so let's go ahead and implement these three methods. So from the client's perspective, what happens when we need to send an operation to the server? Well, it's actually all pretty straightforward. We're going to do server client context dot on operation request, passing in code and parameters. That's it. So instead of shooting this dictionary and operation code into Photon, then having Photon send it over the wire to the server, and then having the server send it to the client, the peer, and then having the peer send it to the client context, we're just doing that all right here. We're just cutting out all that networking code by immediately invoking this on the server object. And that's exactly what I was going for with this architecture, to be able to do this. Okay, as far as these two methods, we have send data and send operation response. These are the methods that the server relies on. So what happens when we send data? Well, remember that we have these base methods, such as handle event. Remember handle event? That's implemented in the client transport base. This handle event method, which is usually called from the Photon peer listener on the client. Well, just like what we did with the on operation request, we're going to invoke that directly in memory without a networking middleman. So we're going to do handle event, add event, event data code, and then, or we'll have to cast this to event code, event code. And then we're also going to pass in event.eventData.parameters. And then we're going to get some warnings here, probably because I am not referencing the Photon socket server. So you will have to go ahead and add a reference to Photon socket server for this to work, because event data is a class that came out of that assembly. An easy way to do that if you have ReSharper is just to hit the magical Alt-Enter and add a reference to Photon Socket Server. If you don't have ReSharper, just head on over to your project in your Solution Explorer, right-click your references, add reference, hit Browse, make sure you back up I was already there, but make sure you back up to your root of your project, go into lib, go into Photon Server, and then select photonsocketserver.dll and hit add. Once you have that done, just hit OK, and those errors should go away, as you saw they just did. All right, what about send operation response? Well, actually, that's pretty much exactly going to be similar, or going to be the exact same. We're going to pass this off into the base method that was given to us by the client transport base. So I'm going to say handle system callback, passing in code and parameters. So hopefully you guys can see how this is just kind of a glue between the client objects and the server objects. Now that we have that done, let's go ahead and start putting together our isolated tests. So I'm terrible at terminology, so I just came up with the term isolated just to describe tests that don't use the production server systems. These tests are how we're going to test the base infrastructure of the system without having the implementation details of the MMO to worry about, such as the quest system or the inventory system, right? All that fun stuff is ignored. And it's also a great way just to exercise this framework and see how flexible it is and how it can be used in different circumstances. So the isolated tests are going to need to have the concept of a isolated system base and an isolated client base. And it's also going to have an object that's responsible for representing a single player in memory. So let's go ahead and do that. So in end-to-end, I'm going to go ahead and create another namespace, and it's going to be called isolated. We can do isolated. Nah, just isolated. The word tests is pretty much implicit in all of our namespaces. And I'm going to start off with creating a class. It's going to be called isolated player. Now, the isolated player class is going to, again, represent a player that is, it's going to represent both the server side and the client side at the same time. And what I'm going to do is I'm going to actually separate out the concerns of the server side of the isolated player with the client side of the isolated player in order to make the syntax a lot more explicit so that we'll know when we're working against server objects or client objects. If you're not really able to visualize what I'm saying here, it'll make a whole lot more sense once we see our tests and how they end up being written. Before I go ahead and write these classes, which I'm going to write as nested classes to isolated player, we're going to need a handful of attributes. So I'm going to kind of break the tradition or the convention of having more than one class per file here, because these attributes are nothing more than just ways to select types out of an assembly, just a way to annotate a class so that we can scan it with our type registry and so on and so on. So we're going to need a handful of these. I'm going to say public class, and we're going to need an isolated component attribute. And he's going to inherit from attribute, which we get through the system namespace. In addition, I'm going to put in a attribute usage here, and I'm going to say attribute usage on interface. Oh, come on. ReSharper hates me tonight. All right, we're gonna restrict it to just interfaces because this attribute is going to be used to create test component interfaces. So you know how we have like our login system with those two interfaces, the login client, login server, and they both have that attribute on them. This is basically what we're going to be using for that. Next up, we're going to need to have an attribute that's able to select out the client implementations. So what I'm going to do is I'm going to say public class isolated client system attribute inherits from attribute. And I'm going to put an attribute usage on him to be class. Again, if you have ReSharper, it's really, really fast doing enums because basically you can just say AT for attribute target, then dot, and then just C. So at.c with ReSharper installed will bring up attribute targets.class. Okay, so that's how we're going to select out the client systems. But our isolated tests also, unlike the real tests, need to have dummy server systems. So I'm going to say public class isolated server system attribute. And he's going to have an AU, or attribute usage, of AT class. Okay, so those are our three interfaces that we need for the isolated player. Now, the isolated player, I think what I'm going to do here is I'm going to write the implementation of isolated player, which is two properties and a constructor. Then I'm going to write out the class for the isolated player client and the isolated player server, and they're going to be nested classes underneath this class. So bear in mind that I am going to be writing code against classes that don't exist yet. So it's important to understand that. So I'm going to just say public isolated player client, and I'm going to call this guy client with a public getter and a private setter. Then I'm going to create a public isolated player server, and I'm going to call him server. I could technically not have these two classes, the isolated player client and isolated player server, but like I said before, by putting the responsibilities of the client objects into one class and putting the responsibilities of the server objects into another class, it really enforces the concept here that this isolated player class represents the objects that live both on the server and the objects that live on the client, and it separates them out and makes things a lot less confusing. All right, let's go ahead and work on his constructor. Now, his constructor is going to need a couple things. He's going to need a server context, so that server context is going to come out of the buzzmmo.server namespace. He needs this because, again, he's going to have to instantiate his player context. So we're going to do server context, and we're going to call this server context. And then we're also going to need a serializer. So I'm going to say iSerializer, or yeah, iSerializer, where are you? iSerializer right there, and serializer. Okay, so how is he going to sort of manage his client and his server? What I'm going to do here is I'm going to say var transport equals new in-memory transport. So that's that class that we just created that's going to be the glue between the server and the client. And then I'm going to separate these out with comments here. I'm going to say client object graph, and it's going to be client equals new isolated player client. Now, we haven't created the isolated player client yet, but I already have a good idea of what he's going to need in his constructor. First of all, he's going to need the transport, and he's also going to need the serializer. Actually, you know what? I don't really even need that comment there, because they're just going to be two lines. Because we're going to also have the server equals new isolated player server. What does the server need? Well, the server is going to need a server context, and he's also going to need the transport. Actually, I'm going to do the transport just to be consistent here. I'm going to use the transport first, and then the server context. Which the server context has a serializer on him. I forgot about that, but I'm still going to accept the serializer as a second parameter. And that's it. That's really the isolated player. So let's build up our isolated player client and then our isolated player server. The isolated player client is going to be pretty straightforward. So I'm going to say public. Now that's important. This needs to be a public class isolated player client. And he's not going to inherit from anything. He's going to have a public client systems. And this is important, actually. He's going to have a public buzzmmo.client.systems.client systems. And we're going to call this systems. So why did I fully qualify that? Well, unfortunately, there's a naming conflict between the client systems class on the server and the client system class on the client. That's not actually a coincidence, because I'm really wanting to coalesce both of those classes into the same class at some point. It was a slight design error on my part, and I apologize. But anyway, so to get to it, because we've already imported BuzzMMO server, which has its client context or client systems, we have to fully qualify the path to our client systems. And that's actually, for now, that's all the isolated player client's going to have. Once we start adding more things in, like our interest management and our world and stuff, this isolated player client will do different things. But for now, it's just going to have systems. Now we need the constructor. And we already know what parameters we want to pass into the constructor. We first want an iClient transport. So by doing this, I'm going to be importing client.infrastructure at the top of the file. We're going to call that transport. And then it also needs a serializer. So what I'm going to do here is I'm going to say var system type registry equals new system type registry. And I'm going to say system type registry dot scan assembly type of isolated player client dot assembly, and then type of isolated client system attribute as the selector. So we have our type registry. It's going to scan the test assembly, and it's going to register everything that it finds that has a isolated client system attribute applied to it. Now we can go ahead and instantiate our systems. So I'm going to say systems equals new client systems, which I'm going to actually have to say, I'm also going to have to fully qualify this. I'm going to have to say equals new client. Oh, come on. Don't do this to me. There we go. Systems.client systems. And we need a component map, a system factory, and an operation writer. What I'm going to do is I'm going to actually instantiate all those dependencies line by line above systems just for clarity. So what I'm going to do is I'm going to say var component map equals new component map. Then I'm going to say var activator equals new, or factory, system factory. That's a good name for it. Equals new activator system factory. So what do we pass in here? Remember, our activator system factory needs a base type. Well, we're going to have a base type for our client systems, for our isolated tests, but we haven't written that class yet. So what I'm going to do here is, for the base type, I'm going to say isolated client system. Have I been using system base? Yeah. So it's going to be isolated client system base. And then it needs a type registry and an init system. The type registry is going to simply be the system type registry we passed in. And the init system is going to be an init system method that we're going to be writing here shortly. Finally, we need an operation writer. So I'm going to say system operation writer equals new system operation writer, passing in the serializer and the transport. Okay, so now we have our three dependencies for our client systems instantiated. So let's pass them in. We first pass in our component map, then we pass in our system factory, and then we pass in our system operation writer. And our systems are instantiated. Again, we have two problems with our player client. We don't have our init system method written yet, and we don't have our isolated client system base written yet. So I'm not going to worry about the isolated client system base quite yet. We'll finish that after we get out of this file. But let's go ahead and put together the init system method. The init system method is simply going to be private void init system, and it's going to accept a isolated client system base system and an object proxy. And all this is going to do is this is going to say system.init, passing in ourselves and the proxy. So our isolated client system base is going to have an init method. Or we can just say, we can call this set proxy. Init, set proxy, whatever. This is test code. I'm not too worried about accessibility here or naming as much. Either way, once we write our isolated client system base class, all of this isolated player client code will work. So now let's work on our isolated player server. That's going to be pretty straightforward too. I'm going to say public class isolated player server. He is going to inherit something though. He's going to inherit client context. Remember, the client context type is the server's representation of the client. So the server understands clients in terms of client context. So our isolated player server is going to be a client context because it's the server's in-memory object representation of what the client is. Now we will need to go ahead and create a constructor for it. So I'm going to go ahead and do that. I'm going to nuke that, and then I'm going to bring this down. So I just had ReSharper generate that for me. And for the second parameter here, I'm going to pass in application dot player systems component map, which is not a big fan of doing it this way. I thought a lot about it. Probably going to change it. Code's already written and it's working, so I'm not going to worry about it at the moment. But either way, this is what the constructor for the isolated player server is going to look like. So if you recall, the sync component map is invoked right there. So, yeah. Which reminds me, I forgot something. Now, the isolated player server... Actually, it's backwards. The constructors. We take the transport in first, then we take in the application, so make sure to fix that. So again, all we do is we have it inherits from client context, it has a public constructor, it takes in a transport and an application, it calls the base constructor, passing an application, the player systems component map, and the corresponding transport. But that actually makes me realize that we have forgotten something, or rather I've forgotten something, because I'm dumb. Remember how I said, yeah, it's going to sync the component map right here in the constructor of the client context. Well, I haven't actually wired the player client into the transport yet. So that would have actually turned into a bug in our code, in our tests. To fix that, once you finish your isolated player server, which is just a constructor, nothing more, hop on over back to the isolated player client. And after we instantiate our systems, just simply do transport dot add event reader, and then pass in a new systems event reader, passing in the serializer and our systems as the systems. And we're also going to have to do the same thing. See, this is why I hate things that aren't enforced by the compiler. That's why I love constructors to take dependencies, because when things are supposed to be wired up but they're not enforced by the compiler, you forget them. So after you go ahead and add line 50 right here, connecting the client to the transport, make sure you go back to the server and do transport dot or actually, I'm going to change the parameter here. It's not going to take in an iServer transport. It's going to take an in-memory transport. Or actually... yeah, let's leave it as iServer transport on the isolated player server. And then let's wire it up inside of the isolated player constructor. So inside of the isolated player constructor, I'm going to say transport dot server client context equals server. Again, this is necessary so that the transport, when the client objects send it data, it needs to know which server client context to push that data into. And that's why we're doing that right there. Okay, so really the only thing left is to go ahead and implement the isolated client system base. Okay, so let's go back to the isolated thing. I actually do want to go ahead and create a new namespace here called infrastructure, just to distinguish it from the tests. And then I'm going to move isolated player into infrastructure. What you should also do here is if you guys want to, you can organize these namespaces however you want. But if you do move it into a namespace called infrastructure, either select the file and hit Control-Shift-R and select Adjust Namespaces, or go to the top of the file and change the namespace declaration to .infrastructure. Either way would work, depending on if you have ReSharper installed. Okay, so inside of the infrastructure namespace, we need to create the isolated client system base class. So I'm going to say isolated client system base. Then I'm going to say tick2 because it's going to be a generic type. And then, of course, I'm going to remove the tick2 from the actual class name because that's not valid C#. And it's going to take in tserver and tclient. And then it's going to implement iSystemBase, which is going to import BuzzMMO base infrastructure. I'm going to pass in tserver and tclient. And that's really all it's going to do. And then we're going to implement its 3 members. Remember, it has a dispose member, a server system interface type, and a client system interface type properties. These are just simply going to return type of tserver and return type of tclient. And then dispose, I'm going to remove the throw new not implemented exception. Then I'm going to say protected isolated player dot isolated player client. I'm going to call this context. Then I'm going to say protected tserver proxy. Then I'm going to say public void set proxy, taking in an isolated player dot isolated player client. We'll call this context and an object proxy. And then we're going to say context equals context and proxy equals cast to tserver proxy. And if I got the name right there, which I'm not sure that I did, I completely forgot about something. I completely forgot that our activator system factory, his generic parameter, isn't going to work. I'll show you guys a way around this. But before I do, let's hop back over into the isolated client system base. This is what the class looks like. Pretty straightforward. It implements system base, returns the different types, has our context and our proxy, and has the set standard stuff. Basically exactly what we did with the client. Okay, let's jump back into the isolated player and fix this generic parameter of activator system factory. The problem is we don't actually have a base type, and I'm not interested in making a custom base type for this particular instance. I could make a non-generic base type if I wanted to, but at this point I'm way too lazy. So what I'm going to do is the generic parameter I'm passing in to activator system factory, I'm going to change to iSystemBase, which is also going to require that on the init system method right here, we change this to iSystemBase. And it's also going to require that when we invoke setProxy, we cast it. Oh, wow. Well, we can't cast. This is what I get for not wanting to write more code. I know, I'm a terrible person. All right, let's just undo that real fast and fix it the right way. The right way to use the activator system factory. I wrote the class. I should know how to use it the right way. I was just being lazy. Let's jump back into the isolated client system base tick2 file. And what I'm going to do is I'm going to create a non-generic interface for it to implement. So I'm going to say public interface isolated client system base. And he's going to have a void set proxy method that takes an isolated player dot isolated player client context object proxy. And then I'm going to have the isolated client system base class implement isolated client system base. And then I'm going to change the set proxy method to an explicit implementation. So it's simply going to be void isolated client system base dot set proxy. And this just changes the accessibility so that other things won't be able to invoke this method unless they cast the object into this interface. Okay, so basically all I did was I created a non-generic interface so I could expose this method. So now let's jump back into isolated player and fix this. Again, I hope people are understanding the motivation behind creating a non-generic base type. Because what we have right here is we can't actually use isolated system base as a generic parameter to the activator system factory unless we supplied the server and the client, which we can't do because this is, this is just framework code. We don't know what types they're going to be. Stuff and things. Either way, we're going to change the generic argument we pass into activator system factory to be isolated client system base. And then we're going to change the init system, we're going to change the signature to accept an isolated system base as its first parameter. And that's it. We have our isolated player. It's really not a whole lot of code. We have 2 files, handful of empty interfaces. This is technically one class. I just chose to split them out into other classes for readability. And then we have our client system base, and that's it. We will need to worry about our server system base as well. How are we going to do that? No, our server base we don't have to worry about because we can just use the client system base from the server namespace. That's fine. Now that I think about it. All right, so let's go ahead and throw together a basic test in our isolated. That's not how you spell isolated. In our isolated namespace. So I'm going to say basic system test, or how about systems tests, because we're going to be testing our systems system. I'm going to annotate this with a test fixture, which is going to import the NUnit framework namespace. And then I'm going to create a test, and let's say public void creating a system on the server creates the correct system on a client. Okay, so before we write this test, we need to go ahead and create our components and our systems. So I'm just going to do this as just nested classes. Note, all of these things need to be public. We need to make public interfaces for our components and public for our systems. So I'm going to say public interface, I test component 1. I test component 1 server. And then public interface, I test component 1 client. And I'm going to annotate both of these with isolated component. Now we need our server component and our client component. So I'm actually going to write the server component underneath the public interface. So I'm going to say public class test component, or test component 1 server. It's going to inherit from client system base, which I'm going to extract out of the Buzz MMO server namespace. The context type is going to be isolated player dot isolated player server. The server interface is going to be itest component 1 server. The client interface is going to be itest component 1 client, and it's going to implement itest component 1 server. Or whoops. There we go. And that's our test component 1 server. So now let's do our client. So I'm going to say public class test component 1 client inherits from isolated client system base, passing in itest component 1 server and itest component 1 client, and implements itest component 1 client. I'm going to go ahead and regionify this as well. So I'm going to say test component 1, no methods. Because we're just writing a test to see if when we instantiate it on the server, it instantiates on the client. Also note that we have to annotate our 2 systems. So this is going to be our isolated server system, and this is going to be our isolated client system. And that's it. So now we can go ahead and test it almost. I forgot one of the most important things, and that is the server context. We need a server in order to do this. So what I'm going to do is I'm going to create a class that inherits from server context. Just as our master server context inherits from server context, we're going to do that as well here. So in the isolated infrastructure namespace, I'm going to create a isolated server context class, and he's going to inherit from server context. Don't worry, this is all going to come together very, very, very shortly. Okay, so for our isolated server context, we need to create a constructor that accepts a serializer and invokes the base constructor with the serializer. We also need to override the configure method that takes in the container builder. However, you'll notice that we're going to have a small problem here because we don't have autofac referenced in our tests assembly yet. So go to your references on your test assembly, hit Manage NuGet Packages, go online, and just search for autofac, and wait a year and a half. There we go. That was faster than I expected it to be. And go ahead and install it. And now just go ahead and import autofac at the top. Okay, so what's this going to look like? Well, the first thing we need to do is map our component map. So I'm going to say player systems component map dot auto map assembly, passing in type of isolated server context dot assembly and the attribute selector of isolated server system attribute. So that'll auto map all of, isolated component attribute. That'll auto map all of our components. Then we need to register all of our systems. So I'm going to say system type registry dot scan assembly, type of isolated server context dot assembly, and then the attribute filter this time is going to be isolated server system attribute. Now we have to tell autofac about all the types we just registered. So I'm going to say for each var system in system type registry dot registered systems. I'm going to say builder dot register type, passing in system dot concrete type as self instance per lifetime scope. And that's it. That's our server. Not a whole lot to say about it. I think what I'm going to do also is our isolated server context. I'm also going to add another method on it. I'm going to say public isolated player, and we're going to do public isolated player. We're going to say connect player, and he's simply going to say return new isolated player, passing in itself and then our serializer. So that'll make a little bit more sense once we get to it. In addition, I think I'm going to completely remove this parameter for its constructor, the iSerializer, and instead invoke the base constructor, passing in a new instantiation of our simple serializer. Because in all honesty, we don't really need to configure our serializer on a test-by-test basis, and if we ever do, we can just create an overloaded constructor for that. But I think the simple serializer will meet all of our needs. Okay, now we can go into systems test. So this is pretty much one of the biggest moments here. How can we test all of our network framework code in memory without an actual network connection? And it basically just boils down to this. We need var server equals new isolated server context. Var player1 equals server dot connect player. Then I'm going to say player1 dot server dot systems dot create test component 1 server. Then I'm going to say player1 dot client dot systems dot contains test component 1 client should, which will import fluent assertions at the top, be true. Then I'm going to say player1.server.systems.destroy test component 1 server. And I'm going to say player1.client.systems.contains test component 1 client should be false. Let's hit run. And we get success. Let's go ahead and flip this assertion around to ensure that this is actually working the way we expect it to. Yeah. Worked on the first try. That's cool. But anyway, so this is one way that we can test the framework. And when we go ahead and work on our RPC responses, that's what we're going to basically be doing. As far as the real tests, I'm not too concerned about them right now. The purpose of the real test would be to actually exercise the code within the server master systems. Like, for example, actually test the login system class right here. We can do that. We would just need to put together a different testing infrastructure for that, which really wouldn't be that difficult to do. But I'm not too worried about that right now, because this is really all we need. We need to be able to test, make sure our proxies work, that we can create and destroy systems. And then when we move on to our interest management, we're going to have to worry about that as well and get that all working, which will be fun. But I think this gets us to where we need to be to actually implement our RPC responses. So basically what I'm going to be doing, not in the next video. I think in the next video I want to get into Unity and actually write the Unity implementation for all this. But then after we do that and we actually see this whole thing working with Unity and we're able to do the whole auto updater thing and all that fun stuff, then I'm going to go back into this test and I'm going to we're going to work on our RPC responses. And once we do that, we can actually implement our login logic, which will be really cool. But I think that just about wraps up all I wanted to do in this video. I hope you guys, and yeah, it's a fairly decent amount of code we have here. Maybe not all that bad, but still, the point is, though, is that we can do this. So we could also write tests where we have two players and they get connected and then they do something and they interact and we get to see if they see each other and have all that turned into tests. And I think that's just really important to be able to do that. Anyway, I think that about wraps this video up, and we'll see you guys in the next one.